Hello everyone. Today we will have a look at yet another topic. Okay, this is on understanding the generative design and its influence towards additive manufacturing. I am Dr. Ilangovan from the Department of Aerospace, SNS College of Technology. Now, well, what is generative design? It is an iterative design. Okay, something which the software is able to iterate on its own, and then it gives us a lot of outputs. Now, what is this used for? Now, when we design, we have a lot of constraints, and using those constraints, the designer, within that constraints, try to build up a geometry around the part, the shape, the topology, etc. Now, these topologies, which are not, within the reach of the designer's imagination, can be brought out by the software. Okay. Now, let us look at the process of generative design. Now, if you see in this particular diagram or the picture, the frame is got a particular kind of a shape that is really engrossing as to how it would have been imagined by the designer. Actually, it is not humanly possible. It is given a certain parameters and constraints. The software comes up with multiple solutions and outcomes, and the designer chooses one among that, and then he uses it. Let's go further and then have a look at this process called generative design. The software explores all possible permutations and combinations of the solution, provided you have given the design constraints, and quickly generates the design alternatives. It tests and learns from each iteration and works what works and what does not work. Okay. Now, introducing the generative design. Now, this is a new kind of help that comes from the software or the artificial intelligence that leverages the power of cloud and machine learning, and it makes some design to make process is being made much simpler here. Okay. Now, there could be an STL file of a drawing that is later given, and that could be also be manufactured straight away to a 3D printing. That is how any geometry could be made into by using additive manufacturing. Now, look at this shape now. This shape is again very humanly impossible for us to imagine somebody to conceive a kind of a shape like this. But then it looks quite puzzling, as well as quite beautiful, that that it can be used for this. It serves a purpose, and also there's a lot of advantage that it can bring down the material cost without compromising on the structural strength and that it is intended to. Okay. Another example is also shown here, where the inner material between the two hubs is being removed without compromising the structural requirements of the part. Now, how do we go about making the generative design? First, the designer specifies sets of parameters for the design part, such as the weight, material, size, and the cost. Okay, the cost has to be related to the time or the type of material and the volume of the material that is being used, etc. All that. So that also some kind of a homework has to be done. Now, generation of designs. The generation design software uses the artificial based algorithm to explore and generate thousands of design options. Okay, more the number of options it is given, like more the time it is going to take, but then you can truncate it to the required number. Probably you can say I want 50 options, like that. Okay, you will have to go and choose the best option among the generated shapes, and the designer chooses this and for further development to meet the design goal. Now, what he does is that he tries to choose a particular outcome that has been given by the software, and then further process it by tweaking it, or by adding a little more manufacturability, etc., all that, and then tries to process it further. Now, this is one sample of design or iteration that has been given, we have here around 24 options, outcomes given for one given input. Okay. Now, among this 24 outputs, I can, as a designer, I watch carefully on each of the outcome, and then I choose that and then further process on that. Now, how does this do? In order to determine the form or geometry of the design, generative design algorithms may use a range of approaches such as the topology optimization or the biomimicry and the microgenesis. Okay. Now, topology optimization, we know what the difference between these two is that, you see here, there's more works on the shape and the outer geometry of the part. That's topology optimization. The main difference between these two approaches of these algorithms is that it tries to remove the material and tries to reduce the part's weight. That is topology optimization, which is most of us are aware of it. Whereas the biomimicry or the morphogenesis kind of an optimization is that it tries to take the evolutionary approach to the design and then brings out a comparison with the natural designs that are available, and it tries to bring out multiple options based on this. You can see based on the bird, the aeroplane also gets its geometry outside. Okay. Now, these are some of the examples that are being inspired by the biomimicry type, and where you compare this with the lotus, and then based on the lotus you bring out an architecture like this, or the super grove that is available in the garden by the bay at Singapore, where these are all the trees, the entire structure is like a tree, and then it's been conceived as a part of the grove that is being around that, which gets illuminated very nicely during the nights, and then it's a pleasant thing to have a look at. Okay. How does the generative design and additive manufacturing, influence each other? Okay. Now, since the generative design can handle large level of complexity that is impossible for human engineers to conceive, okay, and the additive manufacturing, can need not worry about the complexity of the part. So these two gel together, and then it makes the manufacturing or the prototype much simple. Okay. Now, we have seen a simple example here that you see for the steering and the connectivity between the outer ring and the inner hub, okay, or axle. Now, that is also gets a kind of a shape which is difficult for us to imagine. Now, the role of additive manufacturing in the generative design is that it can enable the fabrication of complex geometries that the generative algorithms often produce. Sometimes single parts can be created that can replace assemblies. So your DFMA, design for manufacturing and assembly, also has been taken care, where we try to bring down the number of parts in an assembly and try to make it into a single part. So this brings down the total cost of the product. So thus both these technologies are a perfect combination and revolutionize the new product design. And softwares like Autodesk Fusion 360 have dedicated module on generative design. While both these technologies complement each other, the design will no longer be conventional. You don't have to think about the conventional way of, where is my curve, and then where is my center point of the curve, what is the radius, etc., whether it is tangential to the next curve. All these things need not be worried. So you start playing with free-form geometry. So free-form shapes are most welcome, and the development of them into a product is no longer a manufacturing issue. Okay. So this gives a designer a lot of freedom to work on, and thus this technology really stands out, and maybe this is the future of the further manufacturing. And thank you very much for your hearing. We will again get back on another topic. Thank you till then. Thank you very much.